So the first part of question 5 is fairly straightforward. It tells us the question is about alkenes. It gives us an equation for the combustion of ethene. It tells us what the enthalpy of reaction is, minus 1318 kilojoules per mole. We'd expect it to be negative because all combustion reactions are exothermic, so they have negative values for delta H. And then it says explain in terms of bond breaking and bond forming why a reaction can be exothermic. So our command word in this case is to explain. It's only 1 mark, so they're not looking for huge amounts of detail, but why in terms of bond breaking and bond forming can a reaction be exothermic. So this is fairly straightforward. We say a reaction is exothermic if more energy is released when the new bonds are formed. So this is the bonds forming in the products than is needed to break the existing bonds in the reactants. So we have an exothermic reaction if we get more energy released when the new bonds are formed than we need to break the existing bonds in the first place. The second part of the question is a calculation. So it gives us some bond enthalpy, some average bond enthalpies for most of the bonds involved in the reaction, and then it says calculate the average bond enthalpy of the carbon-carbon double bond using the average bond enthalpies in the table and using equation 25.1. So command word is to calculate, and it's given me some clues as to what I'm going to need to do that. Okay, so how do we go about doing this? Well, first of all, in order to make my working a little bit easier to follow, I'm going to call what I'm trying to work out X. So the average bond enthalpy of the carbon-carbon double bond is X. With all these sorts of bond enthalpy calculations, we're going to be using the equation that says the enthalpy of a reaction is the enthalpy required to break the bonds, bond breaking, minus the enthalpy that's released when the bonds are made, and in this case that is equal to minus 1318 kilojoules per mole. Now, in order to make sure that we don't miss any bonds out, I always like to write my equation out, but using displayed formula to show me all the bonds. So top of the question, if I just go back up here, it gives me the equation 25.1 in terms of molecular formula. So what I'm going to do is I'm going to rewrite that out using displayed formula. So ethene is 2 carbons, 4 hydrogens with a carbon-carbon double bond. That's reacting with 3 oxygens, double bonded oxygen molecules, and that is making 2 carbon dioxide, plus 2 waters. And that just shows me all of the bonds involved in this reaction, the ones that are going to break in the reactants and the ones that are going to be made in the products. So bond breaking, the energy required to break the bonds, what have I got? I've got 1 carbon-carbon double bond, which is the one I'm trying to work out, so that's my X, plus 4 carbon hydrogen bonds, which from my table is 413, so 413 plus, and you have to be careful not to forget these, I've got to break the 3 oxygen double bonds, so that is 3 times 498, and I forgot to put my 4 times in there. And if I work all that out on my calculator, it is equal to X plus 3146. My bond making, if I look at the bonds that I have to make, I've got 2 carbon dioxide molecules, each one contains 2 carbon oxygen double bonds, so therefore I've got 4 times 805 for my 4 carbon oxygen double bonds, plus I've got 2 water molecules, each one's got 2 oxygen hydrogen bonds, so I've got 4 times 464 for those 4 bonds, and if I work all that out, that equals 5078. Both of these are in kilojoules per mole. Should put my units in as I go. Put those numbers into my delta HR equation. So delta HR equals minus 1318 equals bond breaking, which is X plus 3146 minus bond making, which is minus 5078. And then it's just a case of solving that equation for X. So X equals minus 1318 plus 5078 minus 3146 equals plus 612 kilojoules per mole. So my average bond enthalpy is plus 612 kilojoules per mole. It's worth putting the sign in even though it's positive, just to make sure that you don't forget to do that, and it shows the examiner that you understand that it's a positive sign. Apart from the sign, other things to watch out for on questions like this is not to lose any bonds, but if you write it out like I've done now using displayed formula, then that will help you not to do that. Make sure you get your bond breaking and your bond making the right way round, and don't forget things like the oxygen. It's easy to forget that you've got to break those oxygen-oxygen double bonds as well.